Hello, I'm Tarek Madkour. I'm a program manager on the Visual C++ team. I work on the C++ IDE. In the Visual Studio 2005 release, we made a lot of improvements that will benefit the C++ developer and will make them more productive in writing C++ code. One of the common pain points that we have had in previous releases was that people complained about performance of the integrated development environment. That's something that we have worked hard on, and we have greatly improved for the Visual Studio 2005 release. So for example, startup time is now less than 3 seconds, and it was a lot more than that before. We've also added new features all around the IDE. So for example, on IntelliSense, now we match the compiler. In the Visual Studio 2003 release, we produced a great compiler that's standards conformant. IntelliSense did not match that in the Visual Studio 2003 release, but now in Visual Studio 2005, IntelliSense is as good as the compiler. It understands templates, it understands macro state, it understands namespaces, and it's been greatly improved. We've been able to, for example, browse the Boost library using IntelliSense, which is a great addition. We've also improved browsing, so we've added features like caller browsing. You see who a function calls to and where it calls from. You also get live browsing, which is a new feature. You no longer have to produce browsing files at compilation in order to be able to see definitions and references. Now you get them just by writing code, which is great for productivity. We've also improved the debugger, so if you're using STL, you can get STL visualization for the collections and, for example, a map, and you see it just the elements of the map without having to go into the internal data structure and how it's actually stored as a tree or as whatever else. We've also improved creating projects and project management in general. For example, we allow you to share project properties without having to set properties on an individual project basis, which greatly improves productivity as well. And now I'll take you through a demo of some of these features. All right, so let's start with the demo. I'll start up Visual Studio, Microsoft Visual Studio 2005. And what I will do is I will show you one of our new features, which is File New Project from Existing Code. What I will be demoing is a new Scribble demo. You're probably all familiar with Scribble, the MFC application that allows you to record some strokes on the screen and save them to a file, to a binary file. What I added was an extension to Scribble, which is basically allowing you not only to read from binary files, but also to read from text files. And I added a parser, which I used the Boot Spirit library to write. And I added that to Scribble. So what I will do is I'll import the source code for my parser and the Boost Spirit library, actually all of Boost, into Visual Studio using the File New Project from Existing Code. It asks me what type of projects do you want. I want a Visual C++ project. Where are my files? Here's the parser. I will call the project name parser, and it tells me that it will add these subfolders to the project. I could also add more if I wanted to. I don't want to use Visual Studio to build. I actually use nmake to build this. So next, my build command line is nmake, rebuild nmake -a, clean nmake -a clean. There's no output. This is a library, and I include path. It asks you for the include path because of IntelliSense. If you want IntelliSense, you need to specify that. So I use the boost _1 _31 _10. Next, and I'm done. It's going to add the files to my project, and that will allow me to use these source files with all functionality of Visual Studio. This is going through all of the Boost library, which is pretty big. Okay, so now I can see that it did import my project, and here's the parser. These are the full 4 files I wrote. These are the 2 classes. A class that inherits from the boost grammar, and another class that wraps it for use in .NET code. And here's the boost library, and these are all the files, and here is Spirit with all the files that I'm using. So I guess it did get it all well. So let me see what we actually have in terms of classes. I'm going to search for my impl classes. Parser impl. And this is a new feature in the class view. And now you can actually search inside class view and be able to reduce the big list of all the classes into just what you're looking into. So this is script parser impl. I can actually double click on that and go there. So script parser impl inherits from grammar. Let's go to the definition. And here I am in the definition of parser. So all of this I'm browsing inside the boost library. Let me see what else is in parser.hpp. There's the parser class, and there's the overloaded operator here. And there I am. I can use the navigation bars for browsing. And you should note that all of this is done live. We did not have to compile or build this source at all. In fact, we don't even know how it's built because it's not built in Visual Studio. It's built using makefiles. And you can still go to the references, find all the lists and where every class and member function is actually used, which is a new feature that we added for Whidbey. You no longer have to compile your sources in order to be able to get all the information, IntelliSense information on it. So for the sake of this demo, I already went and added that to Scribble. What I did was I converted from using makefiles into using a the Visual Studio build system. So here's Scribble itself, and that's my parser with its classes. These are the source files, and I only reduced it to use the parts of Boost that I need to. I did not add all of Boost library here. And let's see what we have here. So this is class view. These are my classes here, and this is my parser and parser implementation, and these are the classes in Scribble, and the ones in the normal sample. So let's say I want to show you a new feature that we have in Whidbey as well, which is the call browsing. So you can right-click on Get Parser Result and say Call Browser, Show Calls To. And what this does is it tells you who calls the Get Parser Result function. And you can see here that it's called from Get Result. Now, who calls Get Result? You can see that it's also called from Open Document. Let's double-click on that, and it's a Get Result from Script Parser. And you can also show who else does get results call if you wanted to. This is a feature that we had in VC6, and we're bringing back much enhanced in Visual Studio 2005. We also allow you to do inheritance browsing. So let's say, for example, the main window. You can see the base types in the main window, so it inherits from form. And if you look at form, what are its base types as well? And you can see the container control, and you can go all the way down to object if you want. You can also see what types inherit from form or what types inherit from main window if you want. This is along the lines of improving IntelliSense and browsing that we greatly improved in Visual Studio 2005. One of the things we added as well was the ability to better manage your projects. So let's close these browsing windows. Here I have two projects, Parser and Scribble. And one of the things that you kept telling us you wanted to do was you want to be able to share project properties among these two different projects. Now, there was no easy way to do that, and we added a new feature called Project Property Sheets that basically allows you to do just exactly that, sharing properties across multiple projects. And this is very important for large-scale projects. If you have multiple projects in your solution, this becomes very handy. So what we added was a Property Sheet Manager, and basically what this tells you is what property sheets does my project inherit from? So you'll see that Scribble inherits from a few default property sheets, core Windows library, and it's C++ assembly support, so it's targeting the CLR. And you will see that the parser is also a Windows Dynamic Link library. You can also add your own property sheets and make the projects inherit from. So for example, let's say I want to share some optimization settings. For now, if you look at the parser in its properties, you're going to see that if you go to the C++ optimizer, it uses some custom optimization. And the same for Scribble in the release. You're still using custom optimization. Let's say I want to specify /O2. So what I will do is I added these to a property sheet, and I will say inherit from it. So I'll right click, add existing property sheet, and I called it my common optimization settings. When I look at that, you will see that it says throw /O2 on CL. If you check release now, you'll see that /O2 is the default. You can also inherit from the same property sheet here. And when you look at the release settings now, they're also /O2. Let's say I wanted to modify the property sheet later and make it /O1 instead. You'll notice that I only changed it in one place. Now this release configuration says /O1, and this release configuration says /O1 as well. So I managed to localize my changes in one place and be able to inherit from that. Each configuration can inherit from as many property sheets as you want, and you can have property sheets inheriting from other property sheets, so you have multiple level inheritance, which is a very, very useful feature for large-scale projects. One other useful feature that we added for bigger projects is the ability to build files that we don't know about. So we know about how to build C++ files, how to build IDLE files, and other sorts of files, but we don't know everything. And there are tools out there that you might be using that we never heard of, or even we heard of, but we don't have tools to compile. So for example, let's say assembly files. We have MASM, and you can compile assembly files using MASM, but initially, in Visual Studio 2003, if you added a MASM file to your project, you'd have had to have a custom build step and execute masm.exe on it to do it yourself. What we added was, in Visual Studio 2005, was the ability for you to provide us with an XML configuration file that says, this is a tool that is able to compile this sort of extension, and these are the properties on this tool. And what we will do is we will treat it just as if it was CL or Link or any other tool that we know about, and bring you the nice and pretty property sheet for it. And when you drag an ASM file, for example, we will be able to know how to compile it. So let's say I'll drag an ASM file here. Add existing item. This is the assembly file. And you will notice that when you add the assembly file, you get this dialog asking you, I have MASM that can compile star.asm files. Do you want to use this to compile the file that you just added? And what I'll do is I'll say OK. And now if I right-click on the assembly file, you'll notice that we know everything about how MASM files are compiled, which is a great addition. Let's say, well, we ship a file that tells you how to compile assembly file, but we don't ship anything. For example, if you wanted to compile a YAC file, let's say you wanted to teach us about that. So you're going to add to project tool files, and you're going to add a new tool file. And you're basically going to call it the YAC compiler, and file name is going to be yak.tool. I'll put it in the current directory. And let's add a build rule for it. Command line is, let's say the display name is YAC. Works on the star.y extension. And I'll call that the YAC tool. And the outputs are the same as the input, .yy.c. And let's add one more property. Let's say the -L switch. So you can add Boolean properties, integer properties, string properties, or enumerations if you want. So let's say -L is a Boolean. It's either a thrown or not thrown. So the display name is no line info, and the name is line info, switch is L, and let's add that. So there's the L switch, and now I'm calling yak.exe. Okay. Now I'm going to add this, and you'll notice that now you can compile start.y files with the yak. And if you add OK, yes, I want to save this, it'll ask you that you created it in a directory that's not in our search path. Do you want to add it to our search path in the future? I'll say no. So now we know that yak files, .y files are compiled with this yak. And if you added any yak file and you right-click on its properties, you're going to see the L switch on it if you wanted to. One more thing that we added in Visual Studio 2005 is the ability to target 64-bit platforms. So you'll see here that I have debug and release configurations, and I also have a platform list here. And currently I only have Win32. You can also add Win64 platforms. So let's say for Scribble, I'm going to create a new platform. And this is the Win64 on AMD64, which will use the AMD64 cross-compiler. I'll say add that platform. Okay, now you notice that I have two options, Win32 and Win64. Let me choose the Win64 one. So before I build, I'll just need to remove the assembly file, which I added there, which actually does nothing. So I'm removing this file. Now I'm ready to build. So let's try building that solution. You'll see that's building the AMD64 configuration, and it's compiling all my files, and it's successful. Now this has built a 64-bit image. Of course, I'm running a 32-bit machine, so if I try to run it, it's going to say unable to start debugging that program because, of course, it's an invalid image. And you will see that's in the AMD64 subdirectory. So we did generate an AMD64 binary here. So 64-bit targeting is a new thing that we added in Visual Studio 2005. Previously, you had to use a special SDK for 64-bit targeting. Now that's integrated in the Visual Studio, and turning 64-bit in your project is as simple as adding a new configuration for Win64, and we know how to launch the 64-bit cross-compiler and where to get the correct include files from and everything. All you need to do is just make sure that your source code does compile 64-bit, and you're good to go. One last thing I want to show you is some improvements we made to the debugger. So one of the features that we added was the ability to visualize STL collections. So let's take a look at this solution. It's a very simple application. It basically creates an STL map, and it adds some values to it. So if you run it, you're going to see 8 is last, 1 is first, and 2 is second. Now, of course, you wish debugging it was that simple as well. If you've ever tried stepping into code like that, which I'm sure you have, you know that looking inside the map and trying to find the values is not very easy. So let's actually start debugging and see how Visual Studio 2005 helps you with that. So here I'm going to be stepping through my code. And here's the iterator, here's the map, and I'm inserting values. And if you look at that, if you expand the map, you're going to see they expanded just the way that you saw them on the screen, which is very, very good at quick debugging of them. Of course, if you want to look into detail, you can still do that. You can disable this feature. One other very nice feature is the ability to not only visualize it here, but if you hovered over the variable, you would see the same visualized data. So in fact, you don't even need to add anything to the watch window. You can just hover over any variable while you're in the debugger, and you'll be able to see its value. And of course, visualized if we do visualize that variable. And that was all I wanted to show you for the demo. Okay, I hope you have enjoyed today's demo. I hope you can clearly see how much improvement we have made in the C++ IDE for Visual Studio 2005, and I hope you'll find it as exciting to use as I do find it exciting. For more information about improvements in Visual Studio 2005 and other things about Visual C++, please make sure to visit our MSDN Dev Center at msdn.microsoft.com/visualc, and we'll hope to see you again soon.